Imagine a night sky without stars. No shimmer, no light, just an endless sea of black. For billions of years, the cosmos has been a theater of brilliance, stars igniting like celestial furnaces, galaxies swirling with fire, and supernovae tearing across the dark in explosions brighter than entire galaxies. But nothing lasts forever. Every star carries within it a countdown, a final note in a song of burning hydrogen and collapsing gravity. Some end as fading embers. Others collapse into crushing voids, swallowing even the memory of their light. When the last stars exhaust their fuel, the universe itself will dim. Imagine standing in a city after every lamp, every flame, every spark has gone out. The silence feels heavier. The shadows seem infinite. That is the fate awaiting the cosmos, a time when matter decays, when even black holes vanish, and the universe turns into a vast, eternal midnight. This is not the story of creation, but of an ending, a destiny written into the laws of physics themselves. Join us as we journey to the farthest reaches of time, to witness what happens when all stars die and the universe finally falls into black. In the far future, there will come a night unlike any other. A night when the skies fall silent, when the pinpricks of light we take for granted vanish one by one, until only darkness remains. For billions of years, stars have been the beacons of existence, burning, exploding, shaping the elements that gave rise to planets, oceans, and life itself. Yet even these giants are mortal. Their brilliance is not eternal, but borrowed, fueled by delicate balances of gravity and fusion that must one day fail. Picture the cosmos as a grand cathedral lit by countless candles. Each star is a flame, flickering in defiance of the surrounding void. Some burn steady for trillions of years, others blaze brightly only to die young in violent fury. But no flame lasts forever. One by one, the candles gutter out until the cathedral itself lies in shadow. The silence deepens, the beauty fades. The universe, once alive with fire, becomes a place of absence. This is not a vision of myth, but of science, a future already etched into the fabric of physics. The stars will fall, the galaxies will dim, and the night will grow so deep it will seem eternal. But how does such an ending unfold? And what mysteries lie within the slow fading of the light? Across the vast sweep of cosmic history, stars have been both architects and destroyers. Their nuclear fires forged every atom heavier than hydrogen and helium, seeding the raw ingredients of life into the cold emptiness of space. Each sunrise on Earth is but a whisper of this universal legacy. Yet even as they create, stars carry within them the certainty of death. Their brilliance is a fragile balance, a dance of gravity pulling inward and fusion pushing outward. For now, the night sky is crowded with their light. Hundreds of billions in every galaxy, trillions spread across the observable universe. They shine not just as ornaments, but as engines, powering solar systems, guiding orbits, sculpting the destinies of worlds. But deep time is merciless. Billions of years from now, one by one, even the longest-lived red dwarfs will exhaust their fuel. No replacements will be born. The great stellar nurseries, nebulae once ablaze with newborn suns, will fall dark and empty. The sky of that future will not resemble the one we know. Imagine a midnight where no stars rise, where galaxies themselves fade like dying embers. It is a universe slipping toward silence, and we are only at the beginning of its long, inevitable descent. What truly governs this fading is not chance, but law. The stars obey equations written at the birth of time itself. Gravity, relentless and unyielding, pulls their matter inward, pressing atoms into collisions so fierce they ignite. Fusion is the answer. Hydrogen transformed into helium, energy unleashed in light and heat. This delicate equilibrium is the reason a star shines, the reason night skies glow with scattered fire. But it is a bargain with an end date. As fuel runs out, the balance tips. Small stars cool and shrink into dense, dim embers called white dwarfs, glowing faintly for trillions of years before slipping into invisibility. More massive suns collapse more violently, ending as neutron stars or black holes, exotic corpses where the familiar rules of matter are broken. Yet in every case, the pattern holds. The light ends, the darkness deepens. The laws that birthed the stars also seal their fate. The universe does not resist this ending. It carries the process forward, silently, inevitably. One by one, the cosmic furnaces are extinguished, leaving behind the cold remains of what once blazed with unimaginable power. And beyond those remains lies an even stranger destiny, where the hidden forces of physics guide the cosmos into shadow. Yet the story does not end with the death of stars. Their remnants linger, strange and haunting. White dwarfs, though dim, still radiate the memory of their former fire, glowing like fading coals at the bottom of a hearth. Neutron stars, so dense that a spoonful weighs more than a mountain, pulse faintly through the void, spinning like ghostly beacons. And then there are the black holes, silent predators of space, where light itself cannot escape. These relics become the last actors on the cosmic stage. With no new stars forming, the universe transforms into a graveyard of stellar corpses. Collisions grow rare. Galaxies stretch thinner, their remaining embers drifting apart as the fabric of space expands. To an observer in that future, the universe would feel hollow, stripped of motion, stripped of warmth. But even these remnants cannot defy eternity. White dwarfs will cool to black, neutron stars may decay, and even black holes, seemingly eternal, will one day dissolve. What remains when the very bones of the cosmos turn to dust? The answer lies in the most extreme horizon of time, where physics stretches to its very limits. Among these remnants, the black hole stands supreme. Born from the collapse of massive stars, it is a region where gravity overwhelms every other force, where time and space fold into a single, inescapable trap. To fall within its boundary is to vanish, not just from sight, but from existence itself. For ages upon ages, black holes will dominate the silent universe, devouring whatever faint matter still drifts close. Yet even they are not eternal. Stephen Hawking revealed a hidden truth: black holes leak. Tiny bursts of energy seep from their horizons, a slow evaporation known as Hawking radiation. Over unimaginable spans, far longer than the current age of the universe, this whisper of loss will grow. The giants will shrink. One day, even the largest black holes at galactic hearts will evaporate, releasing their last breath of radiation into the void. Picture it: a cosmos once brilliant with stars reduced to nothing but fading whispers of vanished black holes. A final scattering of energy, weaker than the faintest starlight, spread thin across an expanding darkness. What kind of universe is left when even its monsters have died? What follows is an era of quiet beyond imagining. With the stars extinguished and black holes dissolved, the universe enters what physicists call the degenerate era. Here, matter itself begins to unravel. Protons, the building blocks of atoms, may slowly decay, disintegrating into radiation and leaving no trace of the structures they once supported. Galaxies, planets, even the atoms of our own bodies are destined to fade into nothingness. This decay is so slow, so drawn out, that to measure it stretches language to breaking. Not billions, not trillions, but numbers with more zeros than human thought can comfortably hold. Time itself becomes alien, vast stretches where nothing happens, where silence reigns more completely than we can conceive. In this future, the universe is not empty in the way we know emptiness. It is emptier still, a thin mist of stray particles and fading light, scattered so widely they may never meet again. And yet, even here, the story does not truly end. For there is one final transformation awaiting the cosmos, a destiny more haunting than any before. As the aeons stretch further, the last traces of matter grow rarer still. Electrons and the faintest radiation drift apart, carried endlessly by the expansion of space. The cosmos, once a symphony of light and motion, becomes almost featureless. No galaxies, no stars, no heat to warm the cold. It is the dark era, a universe where nothing stirs, and time itself feels like an abyss without end. This silence is not merely the absence of sound, but the absence of change. Imagine a clock whose hands no longer move, a sea without waves, a night without dawn. For countless ages, the universe lies in this stillness, an endless black canvas without pattern or purpose. Yet even in this void, physics whispers its final decree. Energy itself will thin, dispersing until every trace is stretched beyond recognition. What remains is not simply darkness, but a horizon of absolute nothingness, the last page of the universe's story. And so the universe drifts toward its ultimate fate, the heat death, not a blaze of destruction, but a slow surrender to equilibrium. Every particle, every flicker of radiation spreads so evenly across the immensity of space that no distinction remains, no warmth flows, no energy can be harnessed. The cosmos becomes a uniform sea of absolute stillness. This is the paradox of existence. The same laws that birthed galaxies and life also drive them toward dissolution. Entropy, the quiet ruler of time, ensures that order yields to disorder, that brilliance yields to black. What began in fire ends in silence, not with a crash, but with a whisper. And yet, even this whisper carries weight. For in contemplating the universe's end, we confront our own fragility, our fleeting moment beneath the stars, our lives framed between creation and oblivion. But could there be mysteries beyond this horizon? Might physics still hold secrets unseen? The answer lies not in certainty, but in the shadows of the infinite. For humanity, the vision of this distant future is both humbling and profound. Our entire history, every civilization, every dream, unfolds in what will one day be remembered as a brief, golden age of light. We are creatures born in the fire of stars, sustained by their warmth, guided by their glow. To imagine their absence is to imagine the silence of our own origins, and yet, knowing this fate gives meaning to the present. Against the canvas of eternity, our moments of discovery and wonder burn all the brighter. Every glimpse through a telescope, every equation carved into the language of physics, is a defiance of the darkness to come. In searching for answers, we leave echoes, traces of thought and curiosity that outlast the fragile span of human life. Still, the question lingers: when the universe itself has gone dark, will those echoes matter, or will even memory dissolve into the void? The cosmos offers no reply, only the unbroken horizon of time stretching onward. And so the tale closes where it began, in darkness. The stars that once blazed as beacons of creation are gone, their ashes scattered, their voices silent. The galaxies that painted the heavens have unraveled into emptiness. What remains is not fire, not form, but the quiet rule of nothing. A universe that was once alive with brilliance has become an ocean of infinite night. This is the destiny written into the fabric of reality, from order to disorder, from light to shadow, from birth to death. And yet, within that inevitability lies a reflection. For in the fleeting spark of our existence, we have witnessed the grandeur of the cosmos and asked questions the darkness itself cannot silence. Perhaps that is the true legacy of stars, that even as they fade, they awaken in us a longing to understand, to wonder, to dream. The universe may end in blackness, but the story it tells in its brief span of light is eternal in our minds.